Resources. We are glad that we arrived and we are able to successfully launch this service in Florida. I'm going to go through the details of the launch and the network and all the technical aspects of it. Feel free to stop me anytime. We have 45 minutes or so at this section of the presentation, so back and forth Q&A is highly encouraged. So this is the network. By the way, this is, as far as we know, world's first private IoT network based on the NB-IoT standard for utilities, standalone mode. There are other utilities outside the US are using NB-IoT, but is part of a in-band LTE, inside an LTE carrier, or as a guard band on an existing 5x5 or a 10 plus 10 LTE carriers. In a standalone mode, where it is a pure NB-IoT only signal, this is the world's first ever. So that is an achievement on its own right. Bob mentioned the requirement for FCC license renewal. We need to cover about 1.6 million POPs in this MEA, Jacksonville, Florida MEA. So we needed to cover just over 1.5. We got 1.6 million POPs in these three locations you see there. Right in the smack middle of each of the red location is where the towers are, and I will walk you through some of the specifics of the tower equipment and all the network side architecture in a minute. But those are the three locations you see on the right. You probably can recognize Jacksonville area. On the left is the Tallahassee, the capital area, right in the middle of Tallahassee. So each tower location, we nominally get about 25 miles. Actually, it can get a lot more than 25 miles, but we limit to 25 miles because of the timing advance and in order to use off-the-shelf devices, we are limiting that to 25 miles, but the signal can reach a whole lot more than 25 miles. There is an extended range mode of NB-IoT, which is a public domain information. Dish Networks is currently testing out of 50 miles. That will require some more device side changes, so we wanted to avoid that for now. But standard off-the-shelf devices on band 13 Verizon devices and band 14 AT&T devices can be software upgraded to work on this band to reach the 25-mile radius. The images you see are coming from a planning tool that we used, and I'm going to talk a little bit more in terms of how we went through the network planning process. But that prediction actually turned out to be pretty accurate from what we planned versus what we actually measured. So this is the 200,000 foot level view of the system architecture and the key components that make up the system. Going from left to right, we have connecting remote units endpoints to series of custom assets, and I will talk about the initial implementation use cases in a minute. So the remote units attached to the endpoints attached to the custom assets, and those are what traditionally in the LTE world we call it UE, user equipment. We call them endpoints in this case, and they are essentially made out of LTE chipsets. And Bob mentioned Sequence, and I will go in a little bit more detail about the first endpoint we FCC certified, but essentially they are reusing the LTE ecosystem. We are getting 25-mile range on the upper 700 A block. In fact, most of the sub 1 GHz bands, we will be able to get 25 miles range on NB-IoT. And then on the middle, you see the tower, the main tower. We are reusing one of our partners' existing towers. There's nothing newly built. We are typically 250 feet to about 300 feet above ground, average height. So it's pretty high up. So it's much higher than most of the cellular antennas. So the antenna you see there is a standard 700 MHz panel antenna. So we use Kethees antennas for this initial deployment, and then we had a radio head that we customized to support this particular band combination. At the bottom is the Puloli base station. It's essentially a LTE eNode B that we made some software updates to support this particular frequency channelization and some of the link adaptation we had to do for NB-IoT. But essentially, think of that as a software-defined eNodeB. Through our utility partners, fiber backhaul, the packet gateway can be hosted on inside the cloud of the inside the IT network infrastructure, IT intranet of the utility partner. We also have an option to host the EPC in the appliance itself. There are certain security consideration and routing consideration that makes this functional split different in some deployments, but it's a software-defined network, so we can spin the EPC in either location. On the back end, we are communicating with their existing legacy hidden systems and some of their new innovation lab systems they are experimenting for the new sensors and new modules. We have extreme flexibility in terms of how to route, where to route, and what kind of QoS policies can have for different flows. That's all. One of the benefits of being a part of the LTE family is that these standards are already set, and essentially we put those things to good use here to support different kind of classes of devices. So this is the high-level view of it, and I will get into the specifics of each of the nodes. Just to give a picture view, this is one of them is Tallahassee, other is Jacksonville. You can see it looks and feels like a cellular radio head because it is from LTE family. It's much more smaller than what you would see for Verizon AT&T, because Verizon and AT&T have a multi-band and wideband radios, so they are a little bigger and bulkier, but this is much more compact and smaller and lightweight. And on the right you see that's a Ketheesan antenna, the standard 700 MHz panel antenna that you see for cellular. As I mentioned, average height is around 250 to 300 feet above ground. So this is the first endpoint that we launched. As Bob mentioned, it's based on Sequans. There is a company out of France, and they have a pretty dominant market share in Europe and the US. And AT&T, Verizon both use them quite extensively for band 30 and band 14 IoT devices today. So what we did was we used that chipset as is, no hardware change, no RF front-end change whatsoever. What we do is do a firmware upgrade. So with a firmware upgrade, we could program and tune this chipset to the this 1+1 upper server. And we took it through FCC certification. It is an FCC certified device now.